Video, we're going to continue from the video about the graphs of quadratic functions, and we're going to look at quadratic models. In other words, word problems dealing with quadratic functions. So one of the things I kind of mentioned in the other video a little bit was the fact that you can have a quadratic facing down and it has some highest point, and we can have quadratic facing up and it's got some lowest point. Both of these happen at what we call the vertex, and the way you calculate that vertex is the negative b over 2a comma f of negative b over 2a. So that's where you determine where these highest and lowest points. In terms of models, we call the y value when the graph is going down the maximum, and the y value when the graph is going up the minimum. So these are the y values are the max and min. Oh, that didn't come out very well. All right, max and min are the y values of the vertex. Okay, so depending on whether it's a max or a min, which y value it is. So what I'm going to say is, find the maximum. They'll give you a function. F of x equals negative x squared plus 20x plus 500. And what you're going to do is you're going to find the vertex. So, way to find the vertex. Again, these can be h and k. Sometimes you see these letters used for that. So, negative b over 2a, negative 20 over 2 times negative 1, so negative 20 over negative 2, 10. And then to find the actual maximum in this case, you're going to plug this 10 in here. So negative 10 squared plus 20 times 10 plus 500. So negative 100 plus 200 plus 500. So it's at 100, so 600. And this is the maximum. And whatever that referred to, maybe this is something to do with how many sales some small group is doing or something, and they want to know, oh, if we sell 10 items, then we'll reach our maximum funding. And you might wonder, well, why not selling more? Wouldn't you make more money? Well, then you might have additional costs come in, and that may be why you're looking at a situation like this, where you might have to have more storage costs and hire more people, and so there might come a point where you start losing money based on that, and then you could maybe do adjustments to your model, based on new information. But that's why you might have a situation that maxes out and then starts going down, even though it seems like you should be bringing in more money. So anytime we talk about maximum minimums, that's what it's looking for. Another common problem that you might see in something like this is you might see something that says 400 feet of fencing was used to create a rectangular corral that is subdivided down the middle are the dimensions of the corral that gives the maximum area. So unlike a problem where they gave us the formula, now they're just giving us information and we have to construct the formula ourselves. So let's see what this is. What is this talking about? It's talking about you create a rectangular fenced in area and you're going to divide it down the middle. So I'm going to call this x, and this x, and then this side up here is y, and this side up here is y. And so we're looking for what are these lengths have to be in order to maximize this area. So what I'm going to start off by writing an equation that deals with just how much fencing I'm using. So 3x plus 2y equals 400. And then I'm going to write a second equation. Since I want to maximize the area, I'm going to write an equation for the area. And the area for this is x times y. We're going to assume this middle fence doesn't really take up any space. So x times y, length times width is rectangle, how you calculate the area. And what I'm going to do is I'm going to combine these two so that I get a formula for area based on just one of these values. And so what I'm going to do is I'm going to do a substitution. So looking at this first equation, I think I'm going to solve for y, since I'd rather divide by 2 than divide by 3. Plus 400, divide everybody by 2. I get y equals negative 3/2 x plus 200. And now what I'm going to do is I'm going to substitute that into my area formula. So instead of my area being based on both x and y, I'm now going to base it just on x, using this substitution from this first formula. So negative 3/2 x squared plus 200x. Now if I look at this equation, just this one, this is a quadratic equation based on x. So if I want to maximize this quadratic equation, what that means is I want to find the vertex. Well, not the whole vertex, just, since I'm just looking for the dimensions, I'm not actually looking for the maximum area, then what I need to do is just at least find that first value, that negative b over 2a value. So negative, again, b is 200, that's the value with the x. 2 times negative 3/2, that's the value with x squared. So this is going to be negative 200 over 2 times negative, that's negative 3. So 200 thirds, or in other words, 200 thirds. I'm going to get 66 2/3. Okay. And now I want to figure out, so that's how long these sides are, 66 2/3 feet. I want to figure out how long the other sides are. So I'm going to plug y, this value, into, this value, what's going on here? All right. Into my y, so negative 3 over 2 times 200 thirds plus 200. So boom, that's going to cancel out. That's going to be 100. So negative 100 plus 200, so 100. So this side's going to be 100 feet. So our dimensions are 66 2/3 feet by 100 feet. That's going to give me the maximum area. So that can be a type of problem you might see. And it may not be, this detailed, but real common maximizing problem would be something like this. And so, draw yourself a picture, figure out what's going on, write an equation for, in this case, like the fencing, and then write another equation based on the area, and then do a substitution. So you can get a quadratic that you can then start doing your maximization for. And then once you have that dimension, you can go and find the other dimension. Now, if I wanted to actually say what is the maximum area, I could plug this back in for my x's, and calculate what that maximum area is. It doesn't actually ask me for that, so I'm not going to do it here, but if I did, that would be the way I would do it. All right, so there's a few different examples of models.